Welcome to sureshbhattclasses. We are solving question on quantitative aptitude topic H.C.F and l.c.m. All the topics of quantitative aptitude are useful for many competitive exams like SSC CGL, Bank PO, RRB, Railways and many government job exams and job interviews. These topics of quantitative aptitude are also useful for many entrance exams like GRE, SAT, ACT, CAT, GMAT and many more. Please watch all my videos on quantitative aptitude topics. In this video we are solving questions on LCM. Our question is, find the least number which when diminished by 11 is divisible by 15, 35, 72 and 96. The given options are option A 10,091, option B 11,081, option C 12,671, option D 15,079. Before solving this question, I request you to please like, share and don't forget to subscribe this channel. We can solve this question from the given options. On observing the numbers 15, 35, 72 and 96, if we divide the given options after subtracting 11 from the options, then the numbers given in the option must end with 0. Because if the numbers have to be divisible by 15 and any even number, that is 72 or 96, then it must end with 0. For being divisible by 15, the number must end with 5 or 0. But if it has to be divisible by 72 and 96, then that number must end with 0, not with 5 or any other digit. Further, as 72 and 96 both are divisible by 4, so the number must also be divisible by 4, as well as it should be divisible by 9 as the number is divisible by 72. We subtract 11 from the option 1 and the number becomes 10080. So it is divisible by 4 and the sum of the digits is 8 plus 1 is 9. So it is divisible by 9 and it's also ending with 0. So option A might be our answer. Now we check all other options. We subtract 11 from option B. Then this number becomes 11070. This cannot be our answer because it's ending with 70 and 70 is not divisible by 4. So option B cannot be our answer. Now we subtract 11 from the option C. And the number becomes 12660. This is ending with 0 and the 60 is divisible by 4. Now we have to check the sum of the digits. 1 plus 2 is 3. 3 plus 6 is 9. 9 plus 6 is 15 and 15 is not divisible by 9. So option C cannot be our answer. And option D, if we subtract 11 from 79, it is 68. And 68 is not ending with 0. So option D cannot be our answer. It means that option A must be our answer. If we are able to solve the question from the given options, then we should select the option and save our time and go to the next question in any competitive exam. Now I erase these numbers and we will solve it by regular method. We write all the numbers 15, 35, 72, 96. On observing the numbers 72 and 96 both are divisible by 24. So we directly divide it by 24. We write 15 as it is. We write 35 as it is. 24 divides 72 for 3 times and 96 for 4 times. Now 15 and 3 are divisible by 3. So we divide these by 3. 3 divides 15 for 5 times we write 35 as it is. 3 divides 3 for one time, we write 4 as it is. Now we divide by 5. 5 divides 5 for one time and 5 divides 35 for 7 times. We write 1 as it is and 4 as it is. Now 7 and 4 are co-prime numbers. So we can directly find the LCM by multiplying these numbers. So LCM equal to 24 multiplied by 3 multiplied by 5 multiplied by 7 multiplied by 4. 24 times 3 is 72. 72 times 5 is 360. 360 times 4 is 1440. Now we multiply 1440 by 7. 7 times 0 is 0. 7 times 4 is 28. We write 8 and carry 2. 7 times 4 is 28 plus 2 is 30. We write 0 and carry 3. 7 times 1 is 7 plus 3 is 10. So our LCM is 10,080. Now, as per the condition given in the question, we have to add 11 to this number. Therefore, 10080 plus 11 equal to 10091. We had added 11 because on dividing this number by 15, 35, 72 and 96 must leave the remainder 11, or on subtracting 11 from this number, the number must be divisible by these numbers. That's why we have added 11 to it. So our answer is 10091 or 10,091. And from the given options, our answer is option A, 10091. I hope you have understood the shortcut method of finding the answer from the options and the regular method by which we have solved this question. We go to the next question. Our question is, find the least number which when divided by 12, 15, 20 and 27 leave the remainder 5 in each case. The given options are option A, 545, option B, 525, option C, 535, option D, 550. Before solving this question, I request you to please like, share and don't forget to subscribe this channel. We can easily solve this question from the given options. We have to first subtract 5 from each option, as the remainder given to us is 5 in each case. So we will first subtract 5 from the given options, and then the number which we receive after subtracting 5 must be divisible by 15, 20, 27, 12. As it is divisible by 20, then number must end with 0. So we check it after subtracting 5 from each option. Option A, the number becomes 540. This is ending with 0. 525 becomes 520. This is also ending with 0. Option C becomes 530 after subtracting 5 from 535. This is also ending with 0. And option D is 545. This is not ending with 0. So option D cannot be our answer. Further, as the number is divisible by 27, it means that it is divisible by 9. If the sum of the digits is 9 or divisible by 9, then that will be our answer. Option A, the sum of the digits is 5 plus 4 is 9. It is divisible by 9. So option A might be our answer. The sum of the digits of option B, 5 plus 2 is 7, not divisible by 9. So option B cannot be our answer. Option C, 5 plus 3 is 8, is not divisible by 9. So option C cannot be our answer. So only option left is option A. It means that option A must be our answer. Now we solve it by another shortcut method of finding LCM. The largest number here is 27. The next largest number is 20. There is nothing common in between 27 and 20 as both are co-prime numbers. So we will have to multiply it by 20. Now the third number is 15. 15 is 5 multiplied by 3. 5 is included in 20 and 3 is included in 27. So 15 is included in 27 multiplied by 20. The another number left is 12. 12 is 4 times 3. 3 is included in 27 and 4 is included in 20. So 12 is included in 27 multiplied by 20. It means that our LCM is 27 multiplied by 20, which is 540. Now the remainder is 5 in each case. So we add 5 to it. So 540 plus 5 is 545. And this is our answer. It means that option A is our answer. Now we solve it by regular common division method. 12, 15, 20, 27. 12 and 20 both are divisible by 4. So we divide it by 4. 4 times 3 is 12. We write 15 as it is. 4 divides 24 5 times. We write 27 as it is. Now we divide this number by 3. 3 divides 3 for one time. 3 divides 15 for 5 times. We write 5 as it is. 3 divides 27 for 9 times. Now we divide these numbers by 5. We write 1 as it is. 5 divides 5 for one time. 5 divides 5 for one time. And we write 9 as it is. Now our LCM is 4 multiplied by 3 multiplied by 5 multiplied by 9. 9 times 3 is 27 and 5 times 4 is 20. 27 multiplied by 20 is 540. Now from the given condition, the remainder in each case is 5. So we have to add 5 to 540. 540 plus 5 is 545. And this is our answer. And from the given options, our answer is option A, 545. I hope you have understood all the methods of solving this question. We go to the next question. Our question is, find the greatest number of 4 digits which on dividing by 3, 5, 7 or 11 leave remainder 1 in each case. The given options are option A, 9421, option B, 9241, option C, 9888, option D, 9239. Before solving this question, I request you to please like, share and don't forget to subscribe this channel. We can directly solve this question from the given options. As in the given numbers, one number is 5 and the remainder given to us is 1 in each case. So from given options, if we subtract 1, then the option must end with 0 or 5. Option A, if we subtract 1, it ends with 0. Option B, if we subtract 1, it ends with 0. Option C, if we subtract 1 from 8, it ends with 7, which is not 0 or 5. So option C cannot be our answer. Option D, if we subtract 1 from 9, we get 8. So option D is not ending with 0 or 5 after subtracting 1 from it. So option D cannot be our answer. Our answer must be from option A and B. Now how to reach to the correct answer? We subtract 1 from these numbers, option A becomes 9420 and option B becomes 9240. If we check divisibility by 11, the sum of the digits at odd places is 9 plus 2 is 11 and at even places is 4. So 11 minus 4 is not 0 or 11. So option A cannot be our answer. So we cancel our option A. Now only option left is option B. It must be our answer. Then also we check the divisibility by 11. The sum of the digits at odd places is 9 plus 4 is 13 and even places is 2. So 13 minus 2 is 11, which is 11 or 0. So 9240 is divisible by 11. It means that option B must be our answer. I hope you have understood how can we solve such type of questions using the property of numbers. Now I erase this and we will solve this question by regular method. Over all the numbers 3, 5, 7 and 11 all are prime numbers. So their LCM must be their product. 5 times 3 is 15. 15 times 7 is 105. And 105 multiplied by 11 is 100 multiplied by 11 is 1100 and 5 multiplied by 11 is 55. So it is 1155 or 1155. Now the greatest 4-digit number is 9999. Now we divide this by 1155. It divides for 8 times. 8 times 1155 is 9240. And 9240 is that greatest 4-digit number which is divisible by 3, 5, 7 and 11. Now the remainder in each case is 1. So we will add 1 to it. 9240 plus 1 is 9241. And this is our answer. And from the given options, our answer is option B, 9241. I hope you have understood the shortcut method of finding the answer from the options and the regular method. We go to the next question. Our question is, let A be the least 5-digit number which on dividing by 8, 12, 15 and 20 leaves remainder 5 in each case. Find the sum of the digits of A. The given options are option A 5, option B 6, option C 9, option D 14. Before solving this question, I request you to please like, share and don't forget to subscribe this channel. We first find the LCM of 8, 12, 15 and 20 by common division method. Its LCM is actually 120, but we find it to learn how to find the LCM. Here the numbers 8, 12 and 20 are divisible by 4. So we divide it by 4. 4 divides 8 for 2 times, 12 for 3 times. We write 15 as it is and 4 divides 20 for 5 times. Now we divide these numbers by 3. We write 2 as it is. 3 divides 3 for 1 time. 3 divides 15 for 5 times. We write 5 as it is. Now we further divide it by 5. We write 2 as it is, 1 as it is. 5 divides 5 for 1 time. 5 divides 5 for 1 time. Now the LCM is 4 multiplied by 3 is 12. 12 times 5 is 60. 60 times 2 is 120. So LCM is 120. Now the least 5-digit number is 10,000. We divide 10,000 by 120. 120 divides 1000 for 8 times 8 times 120 is 960. The remainder is 40. We carry 0. 120 divides 400 for 3 times. 120 times 3 is 360. The remainder is 40. Now 10,000 minus 40 plus 120 is that least 5-digit number, exactly divisible by 8, 12, 15 and 20. And this is equal to 120 minus 40 is 80 and 10,000 plus 80 is 10,080. But the condition given to us is that on dividing by these numbers, the remainder is 5 in each case. So we have to add 5 to 10,080. 10,080 plus 5 is 10,085. Now we have to find the sum of the digits of 10,085. The sum of digits is 5 plus 8 is 13 plus 1 is 14. This is our answer. And from the given options, our answer is option D, 14. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, find the least number which on dividing by 42, 63, 105 and 120 leaves remainders 27, 48, 90 and 105 respectively. The given options are option A, 2505, option B, 2520, option C, 2535, option D, 2550. Before solving this question, I request you to please like, share and don't forget to subscribe this channel. When the number is divided by 42, the remainder is 27. 42 minus 27 is 15. Also, when the number is divided by 63, the remainder is 48. 63 minus 48 is also 15. So we equate this equal to, when divided by 105, the remainder is 90. And 105 minus 90 is 15 again. Also, when divided by 120, the remainder is 105. 120 minus 105 is also 15. So all these equal to 15. It means that when we add 15 to given options, then our answer must be divisible by 42, 63, 105 and 120. If we know this, then we can easily find the answer from the given options. I will show you how to do it. We add 15 to these options. Option A becomes 2520, option B becomes 2535, option C becomes 2550, and on adding 15 to option D, it becomes 2565. As the number must be divisible by 120, so the answer must end with 0, as 120 has 0 at the end of it. So only option A and C ends with 0 when 15 is added to it. It means that option B and D are not our answers. As one of the given numbers is 63, which is multiple of 9. It means that out of 2520 and 2550, that number will be our answer, which is divisible by 9. So we add the digits of the given options. 2 plus 5 is 7 plus 2 is 9. This number is divisible by 9. So this might be our answer. And option C, the sum of the digits is 2 plus 5 is 7 plus 5 is 12. And it's not divisible by 9, as 12 is not divisible by 9. So option C cannot be our answer. It means that our answer must be option A. I hope you have understood how to find the answer from the given options. Now we solve this question by regular method. I erase these numbers. We write all these numbers 42, 63, 105 and 120. We divide these numbers by 2. 2 divides 42 for 21 times. We write 63 as it is. We write 105 as it is. And 2 divides 120 for 60 times. Now we divide these numbers by 3. 3 divides 21 for 7 times. 63 for 21 times. 105 for 35 times. And 60 for 20 times. Now no two numbers is divisible by 3. So we divide it by 5. We write 7 as it is. 21 as it is. 5 divides 35 for 7 times. And 20 for 4 times. Now we divide these numbers by 7. 7 divides 7 for 1 time. 7 divides 21 for 3 times. 7 divides 7 for 1 time. And we write 4 as it is. Now number 3, 4 are co-prime numbers. So the LCM equal to 2 multiplied by 3 multiplied by 5 multiplied by 7 multiplied by 3 multiplied by 4. 1, 5 and 1, 2 will make 10. So we will add 1 0 after the multiplication of all remaining numbers. 4 times 3 is 12. 12 times 7 is 84. 84 times 3 is 252. This is equal to 252, and 252 multiplied by 10 is 2520. This is the LCM. This number is completely divisible by 42, 63, 105 and 120. But the given condition is that these should leave the remainders 27, 48, 90 and 105. For that we have already calculated what number we have to subtract from it, and that number is 15. So 2520 minus 15 equal to 2505, 2505. And from the given options, our answer is option A, 2505. I hope you have understood both the methods of solving such type of questions. We go to the next question. Our question is, the sum of two co-prime numbers is 500 and their LCM is 14,539. Find the numbers. The given options are option A, 459 and 41. Option B, 471 and 29. Option C, 461 and 39. Option D, 469 and 31. Before solving this question, I request you to please like, share and don't forget to subscribe this channel. We can easily solve this question from the given options. As the sum of the two co-prime numbers is 500, on observing these options, the sum is 500 in all the options. Now we have to check it from the product, as the LCM must be the product of that number. Option A is 459 multiplied by 41. If I multiply 400 by 40, it will be 16,000. So option A cannot be our answer. Option B, 471 and 29. I take 29 as 30 and 471 as 450. So it will be 13,000 some odd number, and our given LCM is 14,000. So it is close to the LCM. So option B might be our answer. Now we go to option C. Option C is 461 and 39. I assume 39 to be 40. 40 multiplied by 400, it will be 16,000. And our LCM is 14,000. So option C is not possible. Now option D is 469 and 31. I assume 31 to be 30 and 469 to be 450. Again it will be 13,500. So it is close to 14,539. Now we have to select from option B and option D. So it is easy to multiply these numbers. So I take the option D, 469 multiplied by 31. 1 time 469 is 469 and 9 times 3 is 27. We write 7 carry 2. 6 times 3 is 18 and 2 is 20. We carry 2. 4 times 3 is 12. 12 plus 2 is 14. Now we add these numbers. 9. 6 plus 7 is 13. We write 3 and carry 1. 4 plus 1 is 5. And we write 14 as it is. So 14,539. And that is the same as given to us in question. It means that option D must be our answer. This is the way we can solve this question from the given options. But we will solve it by regular method to understand how to solve such type of questions. Let one number be x, then the second number will be 500 minus x. Now their LCM is the product of these numbers. So we multiply these numbers, 500x minus x square, and it is given that this is equal to 14,539. So rearranging these, we get x square minus 500x plus 14,539 equal to 0. This is equal to x square minus 469x minus 31x plus 14,539 equal to 0. We take x common. So x into x minus 469 minus we take 31 common. It is x minus 469 equal to 0. So this is equal to x minus 469 into x minus 31. This gives the values of x equal to 469 and x equal to 31. These are the two numbers whose product is 14,539. And from the given options, our answer is option D, 469 and 31. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, find the least multiple of 7 which when divided by 12, 15 or 18 leaves remainder 4. The given options are option A, 280, option B, 364, option C, 182, option D, 546. Before solving this question, I request you to please like, share and don't forget to subscribe this channel. We can solve this question from the given options. All the given options are multiple of 7. Now, as per the given condition, when these numbers are divided by 12, 15 or 18, it must leave the remainder 4. It means that if we subtract 4 from it, the answer must be divisible by 12, 15 or 18. So we first subtract 4. So option A becomes 276, option B becomes 360, option C becomes 178, option D becomes 542. Now the number is divisible by 15. It means that that number must end with 0 or 5. And the only number here is 360, which is ending with 0. And no other number is ending with 5 or 0. So option B must be our answer. This is that easy way to find the solution from the given options. Now I erase this and we will solve it with the regular method. The LCM of 12, 15 and 18 is 180. We'll find it also. 12, 15, 18. We divide this number by 2. 2 divides 12 for 6 times. We write 15 as it is. 2 divides 18 for 9 times. Now we divide all these numbers by 3. 3 divides 6 for 2 times. 15 for 5 times. And 9 for 3 times. Now 2, 5 and 3 are co-prime numbers. So we multiply all these numbers. 3 multiplied by 5 is 15. 15 times 2 is 30. 30 times 3 is 90. 90 times 2 is 180. So the LCM is 180. And it is given that the number when divided by 12, 15 and 18 leaves remainder 4. So we assume the number as 180k plus 4. As 180k will always be divisible by 12, 15 and 18 as the LCM is 180 and the remainder will always be 4. So we have to add 4 to it. So that will be our number and this number must be divisible by 7. We write 180k as 175k plus 5k plus 4. 175k is divisible by 7 and we have to make the value of k such that 5k plus 4 is also divisible by 7. If we put the value of k as 1, then 5 plus 4 is 9. That's not divisible by 7. If we put the value of k equal to 2, then 5 times 2 is 10 plus 4 is 14 and 14 is divisible by 7. It gives the value of k equal to 2 and this is the least value of k to make it divisible by 7. Now we put the value of k equal to 2 in 180k plus 4. So 180 multiplied by 2 plus 4 is equal to 180 times 2 is 360 plus 4 is 364. And this is our answer. And from the given options, our answer is option B, 364. I hope you have understood the method of solving such type of questions. We go to the next question. Our question is, find the least multiple of 13, which when divided by 12, 18 and 21 leaves remainders 10, 16 and 19 respectively. The given options are option A, 845, option B, 676, option C, 936, option D, 754. Before solving this question, I request you to please like, share and don't forget to subscribe this channel. We can easily solve this question from the given options. As given in the questions, the number is multiple of 13. So all the given options are multiple of 13. So from that property, we cannot find the answer. In the given numbers, one number is 18. If we divide the correct number by 18, then it must leave the remainder 16. Or when we divide it by 9, it will leave the remainder 7. As when divided by 18, it leaves the remainder 16. If we divide it by 9, then the remainder will be 16 minus 9 is 7. So we take the sum of the digits of all the options and when we divide it by 9, the remainder must be 7. In option A, 8 plus 4 is 12. 12 plus 5 is 17. 17 when divided by 9, the remainder is 8. It's not 7. So option A cannot be our answer. Option B, 6 plus 7 is 13. 13 plus 6 is 19. When we divide it by 9, so 9 times 2 is 18 and 19 minus 18 is 1. So remainder is 1 and it's not 7. So option B cannot be our answer. Option C, 9 plus 3 is 12 plus 6 is 18. And when we divide it by 9, the remainder is 0 and it's not 7. So option C cannot be our answer. Now option D, 7 plus 5 is 12 plus 4 is 16. And 16 when divided by 9, 9 divides 16 for one time and 16 minus 9 is 7. So only option D leaves the remainder 7 when divided by 9. It means that our answer must be option D. And this way we can easily solve this question in any competitive exam. If we reach to the answer fast by this method, then we should go ahead for solving the next question and save our time. Now we'll solve this question by regular method. We first find the LCM of given numbers 12, 18 and 21. We divide these numbers by 2. 2 divides 12 for 6 times, 18 for 9 times, and we write 21 as it is. Now we divide these numbers by 3. 3 divides 6 for 2 times, 9 for 3 times, and 21 for 7 times. Now 2, 3 and 7 are co-prime numbers. So we directly multiply and find our LCM. 7 times 3 is 21. 21 times 2 is 42. 42 times 3 is 126. And 126 times 2 is 252. So LCM equal to 252. Now, when we divide the number by 12, the remainder is 10. So 12 minus 10 is 2. When we divide it by 18, the remainder is 16. And 18 minus 16 is 2. And when we divide it by 21, the remainder is 19. And 21 minus 19 is 2. So this is all equal to 2. And our number must be multiple of 13. It means that that number we assume is 252k minus 2 is multiple of 13. The number close to 252 multiple of 13 is 247. So we write 252k as 247k plus 5k minus 2. And this number must be divisible by 13. 247k is divisible by 13. Now we have to find the 5k minus 2 to be divisible by 13 by finding the value of k. 5k minus 2. If we put the value of k equal to 1, then 5 minus 2 is 3. So it's not divisible by 13. If we put the value of k equal to 2, then it will be 10 minus 2 is 8, is not divisible by 13. If we put the value of k equal to 3, then 5 times 3 is 15 minus 2 is 13 and it's divisible equal to 3. So this gives the value of k equal to 3. Now we put the value of k equal to 3 in 252k minus 2. So 252 multiplied by 3 minus 2. 252 multiplied by 3 is 756 minus 2 is equal to 754. And this is that required number. And from the given options, our answer is option D, 754. I hope you have understood the method of solving such type of questions. Please do a lot of practice from different books and solve as many questions as possible to become expert in solving the questions of quantitative aptitude. Here completes this video. Please like, share and subscribe to this channel, and don't forget to press the bell icon to get the latest notifications. Thanks for watching.